So far, we've been talking about how to handle exceptions. We've seen some nice power to that, that when Python throws an exception, rather than bumping us up to top level, we can actually say, in this case, I know what I want to do, and I can actually write code to handle that exception. And we saw examples of using that to build little data structures. Very nice. We can actually go the other direction as well, though, which is we could decide when to raise an exception ourselves. So rather than returning special values when an error occurs and then checking to see if that error value was returned, we could instead say, you know what, I want to raise an exception when I'm unable to produce a result consistent with the specifications of the function. And for that, we have, not surprisingly, another keyword called raise. And the idea is, inside of the code, I can say I want to raise, using that keyword, an exception, and I'm going to give the name of the error that I want to raise in doing that. It could be an error that's an existing error exception. It could be one that we're going to create ourselves. But typically, it's going to be an existing error exception. So in this case, a value error. And then a message that I want to print out. And typically, that's just a string that I want to have that tells me what was going on. Hopefully, something more valuable than just something is wrong. It may tell me the specifics that were happening when I raised this particular exception. This is now putting me in control of deciding when to raise an exception, as well as now allowing me to do what I did in the earlier part of how to handle that exception when I get there. Let's look at some examples. Imagine I want to take in a list of two numbers, and I want to get a ratio of those two lists. That is, each list I'm going to assume is equal length, and I'm going to get the ratio of the first element of the first list to the first element of the second list, and so on. And I've got a nice little piece of code here. It has a form you might expect. I'm going to set up a list in which I'm going to record the results. I'm going to then run down the length of the first list with a little index going from 0 up to 1 minus the length of the list. And I'm simply going to try and get the ratio of those two things and put it into the thing I'm trying to accumulate. So I'm running try here. What I want to do, though, is deal with a couple of different cases. One is, what do I want to have happen if I get a division by 0? And in that case, I'm just going to put something in here that's called not a number. It's a special thing inside of Python that I'm going to insert saying, I can't return a number here because it's infinite. That's just a standard exception handler. But when I get anything else, I'm going to raise a different exception that tells me I called get ratios with a bad argument. And then finally, I'm going to try and return the ratios. Let's see what happens if we actually run this. So here's an example of get ratios. I load it in, and let's give it a couple of lists. L1, I'm going to say, is the list 1, 2, 3, 4. L2 is the list 5, 6, 7, 8. And my apologies, I'll do that again. L2 is the list 5, 6, 7, 8. And if I call get ratios on L1 and L2, it does what I expect. It gives me those ratios and it ran correctly. Let's define another list. Let's make L3 be the list just 5, 6, 7. And if I call get ratios on that with, for example, L1 and L3, oh, good. It did what I wanted it to do. In particular, it threw an error because I'm trying to index beyond the length of L2. It's one short of the length of L1. And notice up here, I'm indexing over the size of L1. And it did exactly what I wanted. It raised a value error. So it did throw me up to top level because I don't have an exception handler to deal with that. But it printed out my information, not the standard thing that would have happened if I didn't have a particular handler there. The last one I want to do is to say, let's let L4 be the list 5, 6, 7, and 0. And if I do get ratios of L1 and L4, nice. In this case, the exception handler kicked in, because in this case I have a 0 division error, and rather than throwing an error, I said just substitute in that special symbol, not a number, in place of the spot where I would have otherwise put it in. Again, step away from the code for a second. What we're now showing you is I can certainly handle exceptions as they come up, but I can also raise my own kind of error message for different kinds of errors as they occur. In this case, when I got a value error giving me out something specific telling me where I was when this happened. I can use that to control the flow. Let's build on that idea, and let's look at a second example. So as I said, we're managing the flow of the program by raising our own error here. Let's look at an example where we extend that. Let's assume we're given a class list for a subject. And each entry is, as we did in the earlier part, it's a list of two things. A list of the name of the student and a list of grades on an assignment, multiple grades for an assignment. So I might have a little example here of test grades for Peter Parker and Bruce Wayne, and they're both doing pretty well in this class. What I'd like to do is create a new class list with a name, grades, and an average. What's the average that they're doing so far in that? And you can see the kind of output I'd like to get here, that Bruce Wayne's doing a little better than Peter Parker. It's okay. Pick your favorite superhero and what you want to have do better than somebody else. How might I do that? Again, trying to use the idea, which we're going to do in a second, of using exceptions to handle the way we flow through the program. Here's some code that would do the straightforward way of doing it. Little piece of a little function called getStats. It takes in a list, and what does it do? It's going to build a new list, and for each element in that original list, I'm going to take a list of the first element, the second element, and an average of the second element. And I'm assuming I'm inputting things that have a list of names and a list of grades, and it's going to compute that out. An average, of course, just takes that last element, it adds them up using sum, and divides it by the length of grades. And so if I were to do that with a simple little example, here I've got an implementation of that, and I'm going to initially zero out some examples of this to do a simple version, and then I'm going to do a slightly more complicated version. So the simple version is the one that we already have, and if I run this, and then I look at test grades, which is where I asked to put the result, I get what I wanted initially. Sorry, that's test grades, and now let's actually run it. I'm going to do getStats on test grades. And I get the kind of performance I wanted to get. Looks good. Okay, now what I want to do, however, is I want to look at a case where I've got some other entries in here. So I'm going to rerun this. I'm going to reload this file. I've got test grades in. Here's what test grades looks like. It's got Captain America with some grades, and it's got Deadpool without any grades entered yet. And if I do get stats on test grades, I get a division by 0 error. And that makes sense because in that last entry, length is 0. I'm trying to divide by 0. What could I do to deal with that? Well, as we just said, if I got somebody where they don't have any grades, I get that error because I tried to do that division. Why don't I think about handling it using this idea of exceptions? And so, in particular, I want to deal with this case. And here's what I could do. The first one is I could decide to just notify the user that something went wrong by putting out a message. So I'm going to change now average to try to return this. But if I get a 0 division error, I'm going to handle it by printing out some data. And if I go and do that, I'm going to change now my definition of grades, or of average rather. I'm going to get rid of this version of average. And I'm going to load that file in. Again, I'll just make sure I've got the right thing. There is test grades, and it's my list. And if I now say get stats for test grades, great, it ran. Notice what it did though, it made a decision. So first of all, notice on the printout, it printed out no grades data. So it gave me the warning. I handled that error by saying that's what I want to do. But in this case, notice what also happened. There's the flag for the error, but it substituted in a value. And the reason it did is because average didn't return anything. My definition of average doesn't have a return in this case. And as a consequence, the call to average gives back that special thing, the none type, and it inserted none in that spot in the pool. All right, maybe I'd like to say that that's the average for dead pool, but that doesn't make a lot of sense. How could I handle that? Well, I could decide I'm just going to give a student with no grades a 0. Seems like a reasonable thing to do. And now I can change my handler, again catching that zero division error idea, but putting in an explicit return that says not only do I want to print out a note that says something didn't go the way I expected it to, but let me give me back a value that I can run on it. So now let's go and see what happens when we do that. So I'm going to remove this version of average and replace it with one that has that return inside of it. And when I call this, again, let's check and see we're in the right place. Let's make sure that test grades was loaded properly, and it was. And if I now do get stats on test grades, oh good, dead pool now has a 0. Doesn't say how bad or good dead pool is. He just didn't turn any quizzes and he has no grades. And so now what we see here is we still flag the error, but we've changed what gets returned to insert something that makes more sense for the data structure I'm trying to build. And so we can see we can use our own ability to raise errors, but to handle errors, to deal with things in a manner that we want, rather than simply stopping execution and pumping it back up to the user to try and decide how to handle all of that.